Today we are on another integration techniques called integration by parts. So, integration by parts formula, which is derived from the product rule of differentiation, uses the terms u and or v and are specifically chosen based on their differentiability or differentiability properties. The formula is given by integral of u dv equal to uv minus integral of v du. So let's come to how this came about. As I was saying earlier on, this integration by parts is derived from the product rule. But what we did earlier on, which is the substitution, is also the reverse of that of the chain rule. So it goes hand in hand. When you understand the chain rule properly, it be easier for you to also understand the substitution or the simple use substitution. And if you also understand the product rule for differentiation very well, you'll also be able to understand the integration by parts. So let's proceed and do something here. Let's take the formula, the product rule, which is dv, or let me write it this way, ddx of what uv. This means that when you are learning your calculus 1, which is the product rule, we normally apply the product rule when you get two separate functions, right? For example, differentiating x exponents, maybe x, let's say x squared, and they ask you to find the dy dx of this. In this case, we apply the product rule to do this because they are made up of two different functions, which is the x and then exponent of x squared. So in this case, we can say that our u represents this and then our v represents this in the case of product rule, and therefore we can come out with a formula for that. So if in case we are saying that our x represents u and our e exponent x squared represents v, then if we write the function, we are going to get y equal to uv. So now we are assuming that our function is uv. That's why I'm writing something over here. So let's proceed by writing the formula. The formula is d of uv, which is the function, the two separate function, with respect to x is equal to u dv over dx plus v du over dx. What this simply means is that when you have the two functions which is multiplying together, like the u and v, what it means is to differentiate this, multiply by this, and then differentiate this, multiply by this. You are done. So when you differentiate u, you are going to get u prime, and then you multiply by v, and then you bring plus, and then you differentiate v, the other function, right, and then you multiply by u. That is the product rule that I've written here. So coming back to integration by parts, the formula is derived from this, and therefore integrating both sides with respect to x, right? Let me write the formula here. So we can say that we have d of dx of uv equal to u dv over dx plus v du over dx. As I said earlier on, the dv dx is the differential of v, and then du dx is the differential of u, and then we multiply by the u and then the v separately as well, as I explained over here. Now Let's multiply all sides by dx. When you multiply all sides by dx, this dx can cancel this. Now we are going to have d of uv equal to this dx will cancel this dx. We are going to get u of dv and then plus this will cancel this. We are going to have v of du. So this is a simplified form of the function, of which I wrote it earlier over here. Now this is what I have. So in doing this, we can say that we need to integrate both sides. So by integrating both sides, we are going to get, when I integrate d of uv, I'm going to get uv. The integral sign removes this one here if I integrate it, which is equal to the integral of u dv plus the integral of v du. So having this, we need to make u dv the same because that's what we are interested in. So solving for integral of u dv, we will get this theorem, which is the integral of u dv equal to, now if I make u dv the subject here, I will send this one to this part. So if I send this one to this part, if I send this one to this place, then I'll be able to get this one standing alone over here. So if I get it standing alone over there, then the final result is going to be uv minus the integral of v du. So now this is what we call integration by parts. So let's see something here. The idea behind integration by parts is to transform the original integral into a new integral that may be easier to solve. For example, you may be given two functions and those two functions are complex to integrate. So this integration by parts will help us to transform the original function or the original question given into a new form or a new version of it, of which it will be easier to solve. That's the idea behind integration by parts. So by calculating the integral of u dv, which is what? The integral of u dv, of which we have made the subject over here, we obtain a new term. We will obtain a new term, which is what? uv. This will be the new term, uv. That can sometimes be simpler to evaluate or can lead to a cancellation of terms. The remaining integral over here of v du, which is what? The v du, can then be evaluated separately or may have a simpler form compared to the original integral. So what this means is that this was the original function, and applying the integration by parts formula, we have been able to reduce this original function into a term and a separate integral. And this separate integral and a term, the separate integral that we need to reintegrate again, may be a simpler term or form which can be integrated easily than the original form which was given. So overall, the integration by parts formula will allow us to manipulate integrals by transferring the integration from one term to another in order to simplify the problem. That is the whole idea of integration by parts. So the choice of which term to focus on is crucial, right, for achieving this simplification, and we will come to that point. So understanding that this is the final formula for integration by parts, please do well and keep it on your fingertips because you are going to use it a lot. We will be showing you different methods to solve this integration by parts questions, right? Showing different methods. But currently, it is advisable that you keep this formula in your fingertips, and it's going to help you a lot as you progress in your calculus journey. So thank you and see you in my next video.